So I had a question about wire lengths for the end-fed half wave, and I don't think they understood exactly the concept. So let me turn this off here because the fire department's doing a wreck right now. So I just want to show a couple of things. Let me put this stuff up. I was working on stuff here at the table. Alright, so when you're measuring the wire for the half wave, I put knots at the end. You may not want to put knots at the end. But when you measure the wire, measure it, include, this is just black tape here, but include all the way to the end here. Include the knot. So the best, what I do is I will start with the length of wire and I'll put a knot at the end of it and I'll start my measurement from here. So this is 0, and then I'll go and I'll measure out. When I get to the other end, I generally add a foot or maybe more, about a foot to it, so that I can see. I know that, for instance, this is my mark, so I'll pull out some more, fold it over and tie a knot and try to get that knot, and I leave a little tag on it to connect to the transformer like this. But this is the 65 foot or the 130 foot or whatever you're measuring from here, so it'll go from here to here, right? You just have to remember to leave. And if you go ahead and put the knot on the end to begin with, you don't have to worry about that one anymore. Just have to remember to add wire here for this knot. And it takes a good bit of wire to make a knot. And you can do it other ways. There's lots of different ways to do that. But just remember, if you're wanting 3.55 megahertz and you're going to use 64.5 feet of wire, then 135 feet of wire or whatever, just remember, if you cut it at exactly what you want, if you want 65 foot of wire antenna and you cut a 65 piece of wire, when you put the knots on the end of it, it's only going to be about 63 feet of wire or 64.5 or whatever. It's not going to be what you think. So make sure you add the knots into the measurements and add a little tail. Leave a tail at the end of it anyway, because it's got to come around. It's got to come around and connect to, here's the transformer, like this one. I actually just tied this one directly to the bolt there, but I've put them here, and depending on I've put them in different places, different ways. Sometimes I tie it to this. This one, I maybe tie it up here at the top. I don't know. However you do it, just make sure you leave a tag, a little tail, so that you can connect it, and that you leave enough. Just leave enough for knots. Okay. So I'm gonna flip this around. This is one of the ropes that I use portable. This is more or less not backpack portable, but it's this one. I think this is like fishing line, and it's pretty UV damaged. It's kind of powdery, but it is 2 50-foot sections of rope, and there's a little carabiner on the end, and on this end there are, I think this is 3 1 1/4 or 2 ounce weights, just tied up together and just taped up together. And that's just a whoop, 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 whoop. If you do that a couple times, you get really good at it pretty quick. So I'm gonna spin you around here, and you're gonna see my little paper. Alright, so here's my paperwork, and I drew this out. So you want to shoot for 3.5 megahertz, 355. Okay, and here's why. Because 80 meters a half wave of 80 meters is 40 meters, right? 40 meters is, let's see, a 40 meter antenna should be resonant at 3.5 megahertz. Okay, and if you multiply that by 2, this antenna is going to be 2 half waves at, it's going to be 1 half wave at 3.5 megahertz. Okay, a 40 meter wire, and then it's going to be 2 half waves. Wait, 1 half wave at 3.5. I don't know what I just said, but 1 half wave, 40 meters is. See, this is getting confusing. I think this is why it's confusing, because we're talking about 80 meter wavelengths, and we're talking about an 80 meter wavelength. A half wave of that is 40 meters. So let's back up a little bit. To be resonant at 80 meters, the wire needs to be 40 meters long to be a half wave. And it kind of makes sense, but it is confusing. A half wave at 80 meters is 40 meters. That does make sense. And that will be resonant at 3.5 megahertz. Okay? And at 7 megahertz, it just so happens to be a 2 waves. Okay? Let's see. So let me get that where you can see it. There we go. Come on, what happened here? Stop that. What's going on? So 3.5 times 2 is 7. Alright? And then times 2 is 14. Times 2 is 28. Alright? See that? Okay. And the 7 megahertz, there's 2 half waves for 7 megahertz, right? So that split into 3 is 21 megahertz. So that's sort of the concept of what's going on here. So you got 3.5 megahertz times 2 is 7 megahertz, times 2 is 14 megahertz, times 2 is 28 megahertz. Those are the bottoms of all your major bands. Now the 21 megahertz band you also get a pretty good match on, because 7 megahertz times 3 is 21. So at 7 megahertz, the 40 meter wire, 40 meter long wire, is going to be resonant. It's going to be 2 half waves. At 14 megahertz, it's going to be 4 half waves. At 28 megahertz, it's going to be 8 half waves. I think that's correct. At 21 megahertz, it's going to be 6 half waves, because it's 3 of these and that's half of that. Is that confusing? Anyway, but if you cut your wire, which we're going to get to in just a second, and you get it tuned up for 3.5, this should be what you get. Okay? You could tune it to 3.55 and you would get 7.1, 14.2, 28.4, and then 21.3. Okay? And this 21.3 is probably going to be closer to 2 to 1, but it will be there. If you're curious, you want to go farther than that, 3.6 to 7.2, 14.4 is out of band, 28.8 is out of the technician portion, which doesn't really matter to us. 21.6 out of band, and 3.8, 7.6, 15.2, and 30.4 is no good for us. So, I would suggest just shooting for 3.55, 7.1, 14.2, and 28.4, 21.3. Okay, and generally, this 21.3 is, the curve is like this. It goes down here at like 21, and it's like flat all the way to 21.4. Okay, 14 megahertz band is usually pretty good too. And these two, generally, I get less than 2 to 1, depending on where they are and how they're set up. But cutting the wire, I got another slide. No, it's not really a slide. Yeah, I'm Ross, KG4NWE. Remember to measure end to end and add wire for knots. We talked about that already, but I drew out a pretty little example here. You're measuring from here all the way to here. Okay, you got that? And leave a tag for your little transformer, right? And do the same thing on the counterpoise. Nice example. 80 meter to 10 meter. Measure out a half wave. Half wave for 80 meters is 40 meters, or 134.2 feet if you're an American using the crazy math. I don't understand why people use inches and feet. It makes no sense at all. But, I mean, you know, there it is. Best results, cut, include knots, 134 feet. Hang it up, test it, and trim it down to probably around 132 feet. So for 80 meters through 10 meters, 130 feet to 134 feet, including knots. Okay? For 40 meters through 10, you just cut that in half, right? 40 meters through 10, 65 to 67, or 20 meters long. All right? Counterpoise is 4%, so 4.2 meters for 80, or 2.1 meters for 40, which is the same thing as 13 feet 10 inches, or 6 feet 11 inches for 40 meters. Alright, 10 to 28 gauge wire, I'd recommend 14 to 18. I always use 14 because it's strong enough, and it's, you know, it's not too expensive, it's not too much. Anyway, that is what I'm talking about. That is sort of the main idea. So I've only got parts in. Yeah, so if you're looking for 40 meters, remember, if you cut it at 65 feet, it always, for me, and I'll just tell you this, it always comes out to 64 and a half. I don't know why, but when I measure from end to end, whenever I'm done and it's where I like it, it's always 64 and a half or 64, almost 65. So that's usually where it ends up for me. Yeah, and so if you cut a 65-foot wire, then we would leave this part out right here. And 7 megahertz would be 1/2 wave, 14 would be 2 waves, 28 would be 3 waves, and then of course this will be the same. It would be 3 half waves on using the 7 milliliter. Anyway, I don't know what I meant to say there, but there's that. So anyway, there you go. Hope that helps. So, go cut some wire. Make sure you include the knots. And if you need one of these little transformer thingies, I have them in various stages of completion. This one actually is ready to go into whatever. I don't know what I'm going to put it in though. I hadn't decided. It is literally ready to go. You got the element goes there. The ground is here. Counterpoise. And then this gets soldered there and hooked onto there. I don't know yet what I'm going to put it in. I'm going to find something clever and put this on it and then solder that to it, and it'll be good to go. Yeah, I'm going to play with some different stuff. I might use this. I might use this guy. A little Tupperware container. And then put like a 28 gauge wire in here, wrap it up on a little something round, something like this. Put 28 gauge wire on it. Then I'll have the transformer and the wire. Just a thought. I don't know. Yeah, have fun. Go be radioactive. I'm KG4NWE.